This section will cover the setup and the testing of the sample. The test performed is edge crack testing intention. To execute the testing on the samples we have prepared, you will need the following equipment: the mechanical tester, the Mach 1 model V500C or higher model, a single-axis load cell with 250 Newton load range or equivalent with at least 100 Newton tension, a calibration holder and weight, a testing chamber with 4 screws, a camera, and finally a Tensor grip kit with sample mounting plate. And now the testing procedure for the mechanical tester. We'll first calibrate the Mach 1 and the camera. To do so, open Mach 1 Motion software. Using manual controls, raise the stage to its maximum height using medium velocity. Then, secure the load cell on the vertical stage and verify its calibration as per the Mach 1 user manual. Secure the testing chamber onto the base of the Mach 1 and the bottom of the sample holder onto the testing chamber. It is important that the screw holes are facing towards you. Now screw the top of the sample holder under the load cell. Make sure that the pinholes face the front. In order to set up the camera, cut a 15 by 80 mm band of paper which will be used as an ersatz sample. Draw some arbitrary marks on one of its sides. Position the 2 tensor grips on the assembly plate. Clamp the piece of paper, mark side on top, in the tensor grip by screwing the cylinders on each grip. Then, trim the excess edges of the paper sample. Screw the first tensor grip onto the bottom sample holder. The mark side should face you. Carefully take the second tensor grip and align it with the top sample holder. If needed, move the vertical stage down by using the manual controls to adjust the top sample holder position. Then, insert the fixation pin and carefully tighten the attachment screws to secure the tensor grip. Finally, add a white sheet of paper behind the tensor grip. The ersatz sample should be slightly loose. Create and execute the function shown in table lab module. This is to extend the ersatz sample to its zero tension. Now, plug the camera into the computer and open the camera feed in Mach 1 Motion. Click on Camera Setting and a window will pop up. There, you can adjust exposure time and the gain setting in order to get a properly exposed image. Position the camera equipped 25mm lens so that its field of view covers the entire sample. Make sure that the optical axis of the lens is normal to the sample surface and points at its center. When you are satisfied with the exposure and the positioning of the camera, you can remove the tensor grips from the Mach 1 and discard your ersatz sample. Now that the mechanical tester and the camera is set up, we'll create the sequence shown in the lab module before mounting the sample onto the mechanical tester, depending on the type of material you're about to test. Using the protocol, we'll add a zero load as the first function, and then a find contact in the negative direction for a tension test, with a stage velocity of 0.1 mm per second and a contact criteria of 1.5 GF, a stage limit of 20 mm, and no stage repositioning. We will then add a zero position followed with a move relative function with a travel range and the velocity according to the sample you are testing. Make sure to give a saving path for the move relative function only, and save it as group number, team number, ldpe.txt, or group number, team number, skin.txt, according to the test material. And now we are ready to mount the sample on the tensor grips. The mounting of the samples for tensile test requires the LDPE sample or the RadSkin sample according to which one you are testing, a cutting board, tweezers, tensor grips, cylinders, screws, an assembly plate, and an Allen key. Position the 2 tensor grips on the assembly plate. Then position your sample on the tensor grips. Make sure that the incision is centered, that the painted side is on top, and that the sample stays perpendicular to the grips. Screw 1 cylinder on each grip and make sure the sample is still centered. Tighten both screws of each cylinder alternatively to evenly compress the sample. Note that the skin tissue relaxes after compression. Therefore, wait a few seconds and tighten the screws one more time for the skin sample. Now you can measure the cylinder to cylinder distance and report it as L0. You can now fasten your sample onto the Mach 1 similar to how it was done with the URSAT sample, and click on Execute to start a test sequence.